Okay, so again, if you are comfortable with what was on that test, you're going to find this stuff to be a nice transition for you. So let's talk a little bit about what we should know how to do up to this point. All right, this is going to be a reminder to you. So I'll put recall. If you are given something like 2x minus 4y equals 12, or maybe I give you something like this, y equals negative 3x plus 7, then those are both examples of what we called linear equations in two variables, right? That's what we said these were called. So I'll put that next to this. These are linear equations, two variables. Then you should know how to graph these, right? How would you graph that first one? If you were given the options, I just told you, hey, graph that line, how would you do it? Anyone have a preferred method for that first one? You would do like X-intercepts, then find Y-intercepts. That's what I would have done there also, right? You could have taken this first one to find the X-intercepts. You set Y to 0, solve for X, find the Y-intercept, set X to 0, solve for Y, plot those 2 points, and you're in business, right? Now, on the other version of this linear equation, two variables, the only difference is that, well, it's not the same line, okay, but this is just a different example. The difference between those is that the second one is already solved for Y. So what method would you use for that one? The Y equals mx plus b, right? You know the Y-intercept is 7, and then you know the slope is negative 3. So you could plot your Y-intercept, then go down 3 to the right 1, down 3 to the right 1, just plot a couple of points. So everyone in here should be able to do this and feel comfortable with both methods, all right? So if you're given that, then you should be able to graph using the intercept method or the slope intercept method. Okay? That's what we're going to go to start with. Now, we're going to do sections 4.1 and 4.2 today. Well, they have us only doing 4.1. We'll see how far we get. The difference of what we're doing today and what we did before is, notice that we still have in the title of this section linear equations, right? I still have linear equations in the title of this chapter. But now I have this additional word, systems. Systems of linear equations. And that changes things, right? What systems of linear equations means is that we have more than one equation that we're trying to graph at the same time, you could say. More than one line that we want to graph. And there's something interesting about when you do that, when you draw two lines on the same piece of paper, there's something interesting on that graph that we're going to be trying to find. So let's take a look at an example here. Go to a new page. Your first example. I'd like for you to look at this line. X plus Y equals 10. Everybody agree that's a line, right? That's a linear equation, two variables. Can somebody give me an example of a solution to that? Give me an X and a Y that works. 5 plus 5. So 5 for X, 5 for Y. Okay, another example. 2 and 8. 7, 3. We could go all day, right? Those are all examples of points that satisfy that equation. But now I'm going to add to this another equation let's say 2x minus y equals 11. Now, can anybody think of an answer for that one? Okay, let me draw an arrow. These were solutions here, right? Those were solutions for this one. For this one, solutions, what did you say, 6 and what? 6 and 1. Do you all agree that that would work in the second one? 2 times 6 would give you 12. Take away 1, you'd get 11, right? Anyone else think of another one? How about 10 and, if I pick 10 for x, what would y have to be? 2 times 10 is 20. Take away 9 and you get 11, right? 10, 9 works, right? Again, we could go all day with this. What we're interested in today is not sitting here and finding points that work for each one. We're going to now try and find a point that works for both of them at the same time. You all understand what I'm saying? Can you find an x and a y that actually make these two equations true at the same time? So what we do is we put a big brace in front of the two linear equations like this, and that creates what's called a system of linear equations. I have two equations, don't I? So can we find something that works for both? Does anyone see it yet? 7 and 3. Notice that 7 and 3 work for both, doesn't it? The question for us, what we have to do now, today, is resolve a method of finding that 7-3 without just guessing. All right, because guessing, it's going to work maybe once or twice, but on a test, there's no way you'll be able to guess the answers. So what we need is a process to do this, all right? Now, the first section in this chapter is to try and find the answer by graphing. So that's what we're going to start with. What we're going to do is we're going to graph each of these lines individually, and we're going to try and see if that graph gives us any information. Okay, so y'all ready to try and graph this? Ready? All right, good. Y'all look excited. I'm kidding, you don't. So we're going to try and solve by graphing. Now I'm going to start on a new page, and I'm going to use lined paper to help me because I need my graphs to be as good as possible. I know with you, you may not have graph paper. That's okay. Just follow with me here. So we have x plus y is 10, 2x minus y is 11. Here's my graph paper. I don't like that. Okay, the two equations we have, here's my system. I'm going to write it over here on the left. X plus y was 10, and 2x minus y was equal to 11. Now, those are lines, right? We just said those are two lines. How would you graph the first line? How would you do it? What would be your method here? Crickets. That's all I hear, crickets. You want to do intercept method on that? Yes? Okay. So how would we do that intercept method? Boy, I really caught you on a slow day, huh? We're talking about this first one. Let's see if we can do this without writing too much down. In that first equation, set y equal to 0, what would you get for x? If y is 0, what's x? 10. So you have an x-intercept of 10. Do you all agree? Now, of course, you might have to do this by hand on the side, but I'm trying to work through this quickly. So that means I go out 10 on the x-axis. 4, 5, 6, 8, 9, 10. And I'm going to put a dot here. Okay, now let's find the y-intercept. So set x equal to 0 in the first equation. What do you get for y? 10 again, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I put a dot there. And once I have 2 dots, I can connect them with a straight line, right? Yeah, it worked out pretty good. All right, what about the next one? How would you do the next one? Y equals mx plus b. Any reason why you would prefer to do it that way? Yeah, look, see on the second one, if you set y to 0, then you'll get 2x is 11, right? And then you divide by 2, you can get a fraction. So you could do that, that's okay. But maybe it would be easier just to grab this one here and solve for y instead. So if I solve that for y, it would become negative y equals negative 2x plus 11. What did I do there? Just move the 2x to the other side, right? Now I need to get rid of the negative y, so I multiply both sides by negative 1. So it becomes y is 2x what? Minus 11. Now this is the form y equals mx plus b, so I can graph that by starting where? What do I do to graph that there? Y-intercept of negative 11. So I go down on the y-axis, 11, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Put a dot there. And then from there, where do I go? How do I get to another point? Use the slope. The slope is 2, which is same as 2 over 1. So up 2 to the right 1. Up 2, right 1. Now I'm going to do a couple of these points. I'm going to go up 2 and to the right 1 again. Up 2 to the right 1 again. Up 2 to the right 1 again. Just enough where I can draw a pretty straight line. And now I'm going to come in here with my line. I have to try and get these to line up. Man, that's not bad. Well, actually, it's not that great. There we go. Good enough. Wow, it keeps on moving when I let it go. Do y'all notice what were we trying to get? Do y'all remember what we were trying to get? Yeah, we were trying to get that that common point, that solution that solved both of them. What was that solution that we got? It was 7-3, just by looking at it and trying to figure out. Do you notice what that is on this picture? What is it? Look at the point where the two intersect each other. What is that point? 7, 3. And it's no coincidence. The point 7, 3 is the intersection of the two lines. Okay? So the only thing that's really new, right now, is that we have two lines we have to graph, and we have to graph them pretty good so that we can try and figure out where they hit each other. If we can find that intersection point, then we have the solution to the system. Right? So this is your answer. The answer is actually the whole picture with that 7-3 labeled like that. That's what I'd be looking for on the test. So it might be wise for this next test to bring a little straight edge, you know, make sure you got your ID with you or something, because you'll be asked to draw pretty straight lines. All right, should we try another? Of course we should. Can you all smell the lacquer coming off of this thing in here? Anyone? No? I redid my thing this weekend, and it still smells like the stain I put on it. So sorry if you start getting nauseous here. I'm feeling good up here. Okay, let's try x minus 2y equals negative 2 and negative 3x plus 2y equals 6. Now, the instructions here are to solve by graphing. Solve by graphing. So when you look at this problem, what you want to notice is that big brace on the left-hand side automatically tells you I'm trying to solve these two equations simultaneously. I'm trying to find an x and a y that makes them both true. Since I'm saying solve by graphing, that means you have to draw each of the lines and then figure out where they hit each other. Now, probably I'll save it for Wednesday. The next section talks about a different way of doing this. It's a method called substitution. And that method that we'll do on Wednesday has nothing to do with graphing. We won't graph to try to find an answer. All right, we'll do a different way. So on the test, you need to know that solve by graphing means I expect you to draw some lines here. Okay, here we go. Let's start drawing here. What about that first line? How would you like to do that first line? What method would you like? Everyone's all gung-ho today. Please raise your hand. Don't be speaking over other people like that, okay? One at a time, please. All right. First one, how do you want to do it? You want to do the first one, y equals mx plus b? Okay. You can do it that way. I'm going to bring that line right here. X minus 2y equals negative 2. Now, I'm going to tell you the way that I would prefer to do this is the intercept method. Now, let me show you why. If you let y be 0 right now, what's x? Negative 2, right? If I let x be 0, what's y? Well, then I just divide both sides by negative 2, and I get nice numbers. Do you see that? So you can do either way. Either method works. It's just a matter of which one is better for the problem, and it'll be ultimately up to you. I'll show some more work in this one. To find the x-intercept, what do? Set y to 0. That gives me x minus 2 times 0. Man, you can't see that, can you? To find the x-intercept, I set y to 0. That means x minus 2 times 0 equals negative 2, which means x is negative 2. So I'm going to draw negative 2 here for my x. I'll draw it in a second. How about the y-intercept? Set x to 0. That means you get 0 minus 2y equals negative 2, which means negative 2y equals negative 2. Divide both sides by what? Negative 2. So y is what? 1. Okay, so x is negative 2, y is 1. Okay, sign-in sheet's going to come around. make sure you sign in for today. That blue line was for the test day. I don't take attendance on exam days. I figure if you're not here, it's probably going to hurt you more than just one absence, right? Okay, I'm thinking about this. X is -2, Y is 1. I'm thinking that on my graph, I'm going to make my grid a little different here. In other words, watch what I'm talking about here. I'm going to say that every 4 units is 1. So I have like -1, -2, -3. See what I'm saying? Instead of each dash being 1, each little box. 1, 2, 3. Same thing up and down. 1, 2, -1, -2. Okay, let's put those points then. X is -2 is on the x-axis. Y is equal to 1 is up here. Do you see why I did it like that? Instead of trying to do like this, X is -2 here, Y is 1 there. See, those points would be really close together and it might be hard to draw a nice, real good line. So that's why I kind of spread out my grid. All right, draw a straight line through there. I'm going to try and do this by hand, just to see if my line's any good. It's all right. All right, you ready to try and graph the other line now? You all ready? Here we go. The other line, I think I'll use the same method. Okay, I'm going to use the intercept method. So how do I find the x-intercepts? Set y to 0. If I set y to 0, I get -3x equals 6. Which means x is what? -2 again. Okay. What about finding the y-intercept? Set x to 0. If I set x to 0, I get 2y equals 6. So y is 3. Questions? Comments? Concerns? Why didn't I? Just because it was very, I don't want to say easy, but did you notice that when we plugged in like y is 0 and x is 0, we just had nice clean answers? Let me show you what would have happened. Let's say on this first one, I'll just do it over here and I'll erase this. If I had taken x minus 2y equals -2, and I would have solved it for y, I would have moved the x over first, which would have made it a -x on the right. Then I would have divided by -2, right? So I would have had y equals, this would have become a -1x over a -2, and then a -2 divided by a -2 would have been +1, right? So then I would have negative over negative would have been positive, so I would have had y equals 1/2 x plus 1, which I could do this, right? That just means my y-intercept is where? At 1, so I would have started out here. Oh, I didn't want that. I would have started out here at that highlighted yellow. Then to get to another point, I would have gone up 1. That would have been up 1 here, and then over 2, 1, 2, and I would have been on another point on that line. You see that? It would have drawn the same line. On the second one? Yeah, and you should get the same line, but do you see how there was a lot of room for error there? Like there's lots of little sign problems. So I always try the intercept method first if it looks like it's going to work out nice. If not, then I have to resort to the y equals mx plus b. Good question. I'm going to erase all that. Is that okay? Oh, I don't want anyone getting confused. All right, let's get that other line on there. My x-intercept is -2. So here, and then my y-intercept is 3, so I have to extend my graph up just a little bit here. 1, 2, 3, 4. So 3 is up here. And then I draw a line. There's something real nice about this problem. You can tell pretty easily where they hit each other, can't you? Where? -2, you have to look at it as a point. -2, 0. So that's your answer right there. How could you check your answer? Plug it in. Try the first equation. What happens if I replace x with -2 and y with 0? I get -2, this is gone, equals -2, which is true. But then do the same thing on the second one. Plug in -2 here for x. -3 times -2 is 6. Replace y with 0, it's gone, so you get 6 equals 6. So -2, 0 satisfies both equations simultaneously. What do y'all think about this? I mean, you're going to have to practice on your own, obviously, but I mean, it's not like I came in here with some crazy new math today, right? I mean, this is pretty much what we've been doing, just kind of combining it into something, new. Now, you're going to maybe ask the question, why would you ever want to do this? And I'll answer you in a little while. But we need to see another case, another example where something kind of goes wrong. Okay, next example. Let's try this system. -x plus 3y, equals 6, and 6y equals 2x plus 6. Now, I've done something here intentionally. I've kind of scrambled things up a little bit. Like on the first one, -x plus 3y equals 6, that's pretty much a form that we've seen before, right? The variables x and y are on the left, and then we have a number on the right. But on the second one, I kind of moved things around already just to kind of mix it up. But these are both still linear equations in 2 variables, right? Okay, let's try the first one. How would you like to try the first one? What method? XY intercepts? All right, let's try it. Do you want me writing it down, or you just want me to talk through it? Y'all would like to see it? I don't really care. You want to see it? Okay. So for this one, the first thing I'm going to do, I'm going to use the intercept method. So I'm going to find the x-intercepts. So I set y to 0. When I do that, I get -x equals 6. I don't want -x, I want +x. So I multiply both sides by -1, which gives me x is -6. So there's my x-intercept. How about my y-intercept? Set x to 0, and you get what? 0. Okay, yes. I'm going to write it down though. 3y equals 6, right? And then now divide both sides by 3, you get y is 2. Now technically those are points, right? So we can graph these. Sometimes it might be worth it for you to, like if you want to do both the lines and get the points first, then throw it all on the graph, or you could do the first one, graph it, then the second one, graph it. I'll just put this on the graph right now. -6 for my x-intercept. 1, 2, 3, 4, 5, 6 units to the left on the x-axis. And then on the y, I need to go up 2. And then I connect it with the straightest line I've ever drawn. Now do the next one. The next line, the X-intercept, I set y to 0. So I can do it the same exact way, right? All I'm going to do is I'm going to rewrite this equation. I'm going to let my y be 0, which is going to kill off this left side and make it a 0, right? 6 times 0, 0. So my left side of my equation is 0, and then I still have 2x plus 6. Can you solve that for x? This is like what we did first couple of days of class, right? Just move you have to get the variable by itself, so you move the 6 to the other side by subtracting it on both sides. So you get negative 6 equals 2x. And then divide by 2. So x is negative 3. Is that okay? Now the y-intercept. To find the y-intercept, I set my x to 0. So if you do that, what will your equation look like? If I let x be 0, what is it? 6y equals 6. And now to solve for y, divide by 6, y is 1. So go to your x-intercept of negative 3, which is here, and a y-intercept of 1, which is here. Ooh, this is a problem. Do y'all see what's going on? It looks like they aren't going to cross each other, but that all depends on how good my lines are, right? If your lines suck, then you may actually cross each other somewhere. So it's difficult to see from the graph here what's happening. But it turns out that these lines are what? What do they look like they are? Parallel. And do parallel lines intersect? No. So there is actually no solution to this. That means that there is no x and there is no y that you can ever find that make them both true at the same time. So your answer is parallel. Therefore, no solution. A little FYI, in this class, if you ever see me write, math people don't like to write words if we don't have to. Therefore, we write therefore a lot in math. If you ever see me do 3 dots like that, it means therefore. So sometime later on in this class, if I just do those 3 dots in a little triangle like that, it means I'm saying therefore. All right? So these are parallel, therefore there's no solution. Now, what if those lines, if I had done all this work and those lines would lay right on top of each other? What if they were the same line? You know, so let's say I give you 2 equations, you graph one, you get your points, you plot it, you graph the line. Then the next one is right on top of the same line. Then do they hit each other? Yeah, you wouldn't say all real numbers, you would just say infinite solutions, that's all. I'm not going to give you that on a test. I'm just keeping in mind. There's basically 3 possibilities that could happen with lines, with systems of equations. They can hit at one point, they cannot hit at all, and they can hit everywhere. Those are the 3 possibilities. All right. Let's try. I'm going to try to show you an example that, like a little bit of a word problem, just to motivate like where you could use this, I guess. Okay, Jill is 5 years older than Bill. Twice Bill's age added to Jill's age is 72. What do you think my question is? How old are Jill and Bill? That should say 5 years older than Bill, first sentence. Jill's 5 years older than Bill. Twice Bill's age added to Jill's age is 72. How old are they? Well, what we have here, believe it or not, is a system of linear equations. So let me help. First, there are two things we want to know, right? Jill's age and Bill's age. So let's let X be equal to Jill's age. Let's let Y be equal to Bill's age. Okay? What does the first sentence tell you? Okay, so how can I write that in terms of these variables X and Y? X plus 5. Jill, okay, Jill, which variable is Jill? X. X is, what's is? Equals, right? X is 5 years older than Bill. So 5 plus Bill, Bill's Y. So 5 plus Y. If that's all you had, there's an infinite number of answers, right? Bill could be 20, Jill would be 25. Bill could be 30, Jill would be 35, right? But there's more information given. Twice Bill's age added to Jill's age. So how do I write that out? Twice Bill's age, 2y, added to what? Jill's age is x, is equals 72. If I put the brace in front of it, you see what we have? A system of linear equations in two variables. So now what we do is we try and solve it. I made this problem up, so I'm not quite sure what our answers are going to look like here. So let's try this. Yeah, this is going to suck. Let's try the first line. Let me do it with Intercept Method. What's the X-Intercept? How do you find X-Intercept? You set y to 0, don't you? What do you get when y is 0 in that equation? X is 5. Okay, find the y-intercept. You set x to 0. What happens if you set x to 0? 0 equals 5 plus y. Which means y is what? Negative 5. Good. Now, I'm not going to plot these yet, okay? But that's my x and y intercept for that first line. Questions? Let's do the second line now. X-intercept, set y to 0, and you get x is what? 72. Find the y-intercept, set x to 0, and you get 2y equals 72. What's 72 divided by 2? 36. Do you see why I didn't graph these first? Because I knew when I made the problem here that if I would have graphed the first ones, right, 5 and -5 first, then you would have been like, you know, your graph only would have gone out 5, maybe 10 each way or something. And look what we need for the next one. I need to go 72 one direction, 36 the other. Okay, here we go. Let's try and graph these, see if we can make something happen. I'm going to use a rather large graph here. Whoa. Okay, I need to be able to go 70 something, right? 72 in one direction? One direction. I don't keep up with what's going on with music, but the other day I was driving down the road and I was listening to something. I was talking to my wife. I was like, yeah, it's a pretty good song. She's like, this is One Direction. I was like, oh, shut up. Seriously? So I had to like totally withdraw that statement. I felt bad. I mean, it had a good beat and it had a good little rhythm to it, I guess. So I admit it. I like the beat of a song by One Direction. What am I doing here? 72 and 36, right? Let's do those first. What was the 72? It was my x-intercept or y? X. So I need to go 72 on the x-axis. Geez, maybe I should count by fives? Can we count by fives? 5. I'm going to have to delete what I just said on this video about One Direction. I don't want that documented in any way. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. So if that's 75, 72 is kind of like ballpark somewhere in here. You see how I'm having to estimate that? This is where the graphing method that we're learning today breaks down and why Wednesday is much more powerful. You'll see. Now on the y-axis I need 36, so I'll count by fives. Was it positive 36 or negative? Positive? 5, 10, 15, 20, 25, 30, 35, 40. 36, right above 35, right? And I draw as straight of a line as I possibly can through that. And it's going to be real important that I get this line as close as possible. And I realize that's going to be difficult, you know, for you to do, but you get it as close as you can. Now, what were the intercepts of the other one? The x-intercept was what? 5? Was it negative 5? X-intercept? 5? Okay, let me go back. X was 5, Y was negative 5. Okay, got you. The x-intercept is 5, which is going to put me right here. And the y-intercept was negative 5, which is here, which means it's kind of like I have a rise over run, like goes up 1 over 1, up 1 over 1. I can do another one like this. And then let me try and draw a line through here. Now I can see that there is an answer, right? There is an answer, but it's not easy to see what it is it? It's not. And what approximately are these values? Let's see, x's, notice I'm putting the x and y labels on the axes. X is this axis, y is this axis. X was Jill's age, right? and Y was Bill's. What is it saying Jill's is about? Let's count this off. This was 5, 10, 15, 20, 25, somewhere between like 25 and 30 years old, right? Somewhere, this point right here looks like it's between like 25 and 30. And what does Bill's age look like? 5, 10, 15, 20, about 25 to 30 also, right? Do y'all see that? But it's hard to see what it is. Do you see where the graphing method breaks down? Okay, so what we're going to have to do is we're going to have to leave this as an open, unresolved question for our next class. I wanted you to see how you could take a word problem, you could break it down into a system of linear equations, but our graphing method is still weak. So here's what I want you to do. I'm going to turn the lights on. I want you to do one problem. You're going to turn it in for a quiz. It's going to be one of these. I just want to make sure you're okay with this. And then I'll put the homework assignment up. One question, that's all. Make sure you put your name and today's date on the page. That's all I need, name and date. Solve the system by graphing. Y equals negative x plus 4 The next one is y minus x equals negative 2. Below this will be your homework assignment. Okay, there's your homework. I highlighted number 37. It's a little weird. When you get to that on your homework, don't freak out. Just think through it.